Hi guys, today I would like to present you a tutorial, very basic tutorial in Unity 3D on how to optimize your enemies based on a single parameter that you can create in order to control it. So I'm starting Unity and I'm gonna start a new project. Here I'm gonna call it uh, enemy AI optimization. So I will actually present a very basic method, which is a grid-based search method for optimizing uh, the the abilities of your enemy and how we can control or how we can optimize the speed and the detection rates of your enemy using a grid-based search, which is a simplified method of Markov chain Monte Carlo optimization technique. So we have Unity here, and I will create a very basic scene. So for my scene, I will create a simple plane where it is plane, and I will change its size to 5 by 5. And I want it to be also static because I will use the nav mesh functionality. So click this static button and then go to navigation here. If navigation is not shown here, you might need to go to your Windows and then, if I'm not wrong, it's AI, and then click navigation in order to see this tab. So I'm clicking the bake and then bake, and once you bake, you can see your scene is blue. Okay, next thing is I'm gonna create a couple of materials, or for that material folder, and in this folder I will create a couple of materials. So this is 1, 2, 3, I think 4 materials are gonna be okay. So I'm gonna give some colors, kind of random colors. Let's say blue like this for the ground. I will capture the red for the create a red for the enemy, green for the bullets that we'll be using later in another tutorial, and nope, and let's say this for the player. Okay, we have the materials, and I will create the player. For the player, I'm gonna create, let's say the player is a cube. Okay, it is this cube. Let's move it up, and I would also create an enemy. In my case, the enemy could be a capsule. That I will move it here. Let's say here, and it is. I think it's above ground. Okay, awesome. So we have the player and the enemy. Let me assign the materials. The enemy is gonna be the bad guy. It's a capsule. I'm gonna call it, by the way, enemy, and the cube is my player. Let me rename them. And my player is gonna be this guy, so I'm gonna assign him this gray color. Next thing I wanna do is I wanna attach the camera to my player, so I make the camera a child of my player, and I wanna move the camera close to the player so we have a third person view of the scene and the player in general. Okay, one thing that I want to also do is that I need a script that moves the character. In this case, I have already created one, so I will import it and double click it to show you how it looks like. You can search online to find the script to make a player moving around, or I think that you already have it from previous tutorials that Jim created. So I will also attach this script to my player here. I don't need this box collider. Yep, I want to attach it here, and not now. Let's wait a minute. So this is a basic script that we define the speed, the jump speed and the gravity of the player. This script asks for a character controller, so we should go back after we assign the script to our player. We need to search here another component, which is character controller. Okay, and there are some comments. It takes as input the WASD to move around, or the arrow keys to move around, and also we have the jump button, which is the spacebar, in order to jump and make our character move. So after we do this, suppose that if I click play, it will work. I will be able to move around with my character. Yep, my character is moving around. You can see this here. Okay, so it's working. As I said, you can find the script online. There's no need to create on your own. It's not the scope of this tutorial to show you how to create a character that's moving around. So we have our enemy, and I will create another script, and this is the main script that I will work today, which is the enemy AI, and I will attach this script to my enemy. Here. Okay, and this enemy, because we have the navmesh, this enemy is going to be a navmesh agent. So click the add component button at your enemy and search for navmesh agent and select it. So right now it takes, this enemy can take as input information from the navmesh in order to be able to move around. So I will double click here to start the script, and we'll start working on it. So one first thing that we need to define is to access actually the navmesh functionality, or to access the navmesh agent functionality of the enemy that we created. So I will type here private. There's no need to be public variable. So we'll create this private variable, which is the Unity engine dot AI dot navmesh navmesh agent navmesh agent, this one, and we'll call it agent. So based on this, we can access now the navmesh agent functionality of the agent. And the next thing that we need to define is to define the target, which in our case the agent should look at the target in order to move around. So our target is the player. So this can be a simple public transform, and this is, we can give a name like a player target. So this is the game object that we have in our scene, that the agent, the AI enemy, is gonna search and try to reach it by moving toward this position. And the next thing, or before we go there, we can just write a couple lines of code here in the update function to show you how things work. So if we want to make our agent move toward the player, what we need is to access the agent and assign some target position to the agent. So to do so, we type agent dot set destination, this command, and the destination we set is the player target dot position. So if we do so and go back and run this, you can, no, it's not working, because after we write everything here, we might need to assign here the player target, which is the player. So I have to assign the player, because otherwise the enemy doesn't know who to follow. So I click the play button, and you can see now that it's not moving. There might be another problem. No. And it looks like we have a few errors. Let's click one of these errors. Player target, and here we have the okay, yeah. The thing is that we defined this, but we didn't access it yet, so we need to access it here in the start. So we need to access the component. So we'll be using agent equal get component Unity engine dot AI dot nav message agent. Oops, come on, double click it. And this. So suppose right now we have access to the nav message agent functionality, and we click again, and you see that the enemy is moving toward the position of the player. Okay, I'm stopping this now. So we make our enemy follow the player. The next thing is that we might need to define some detection range in order to tell our enemy what to follow or not the enemy to follow or not the player. So in this case, I will create here a simple variable that computes the distance between the player and the enemy, and based on this distance we can define this distance, say that if the distance is greater or less than this one, then follow or not the player. So for this reason I will create another variable, which is it's going to be right now a private float value, which is I will call it float enemy player distance. Float enemy player distance. I will give a value of, let's say, 2. Now the next thing that I have to do is to compute the distance between these two, and this is just a value that this is the distance between the enemy and the player. So I will use this here in the update and compute the distance. So both enemies and players are represented with vector 3 positions, x, y, and z positions. So we'll be using the vector 3 dot distance functionality of Unity, which is this one, vector 3 dot distance, and here within parentheses we'll put the position of the player, which is this dot position, and the position of the object that this script is attached. For this reason, we write this dot transform dot position. So with this transform position, we access the position of the objects that this script is attached. So this script is attached at the enemy, so we access the position of the enemy. Next thing we need is to create a condition that tells us whether or not to follow the enemy. So I will write this if statement that says that if this distance is less than a number, so in our case it could be the range of the enemy. So I will go back up here and define a private float value, which is the agent range, or we can call it enemy range. Enemy range, it's better, and I can give a value equal to 2. So I will add this here and put it within. Oops. So what we have here in these 2 lines of code is the following. We say that if the distance between the enemy and the player is less than the range, then the agent should follow the player, otherwise should not follow the player. So I'm gonna save this, go back to my Unity here and plate. Oops, something is missing. Okay, I think that we solved the problem. Oops. This one. Okay. So now we solve the problem. It doesn't move toward the enemy. I go close, oops, and move. Now it moves. I'm going farther away, it stops because it's outside the range. If I go closer, oops, moves, follows me. I'm a bit faster than the enemy, so I can easily escape from the enemy. But this is the logic behind it. So we can easily now control this range by changing one value. The next thing that we need to control also in order to make our agent a bit more intelligent is the speed of it. So we can create a variable for the speed. So I will create it here as a private float enemy speed. Speed, and I will give a value equal to 10, let's say, for now. And I can also say that assign this speed to our enemy. So agent, to assign the speed, we use the agent.speed function, and we use this enemy speed value here. So in this case, we are able to control the speed of the enemy, which means that if we go close, I don't know if the speed is enough, then this right now it might move much faster than us. No, it doesn't move fast enough. We might need to give a higher value to make it follow us all the time. So we might need to give a speed of, I don't know, let's say 100. You need to find what is the best speed for your enemy. You see, right now it follows me much more because I'm moving less fast. Okay. So right now we have the 2 basic parameters we need for the the enemy. The next thing is that we need to optimize the speed and the detection range for the enemy. So for this reason, we'll create a couple more variables that we need not to define some. We need to define the ranges and also to create a method that iteratively searches to find the optimal speed and detection range for the enemy. So for this reason, we will create a number of variables. So I will start by typing down these variables. The first one is public. I will be using public variables for now because I want to be able to change these variables using the inspector window. So I will create a public float, which is the target difficulty, and I will give a value of 10. You can play with these values later. I will present the very basic approach to solve the problem. The next value we need is private. For now on, I will be using private. What I care is about changing a single value, which is this target difficulty, and this single value is going to affect both the enemy speed and the enemy range. So I define this target difficulty, and then I will create some private variables. The first one that is a private float, which is called current difficulty. There's no need to add the value difficulty. Let me put it here. I will just assign a value of 0. And the next variable that I need is the proposed difficulty. Again, it's going to be a private float proposed difficulty. If I'm not wrong, I mentioned this in our lecture about the target and the current proposed and how to iterate, how this iterative process works in order to use this kind of values or this kind of namings in order to find the optimal solutions and optimize a solution for our problem. I need two more values, which are the random values that I will generate for the speed and the detection rate. So I'll create a private float rand speed and a private float rand detection range. Now, before we move forward, as a debugging process, let's print this value, the enemy player distance, just to be sure that things are working as expected. So I'm gonna print this value here, and this is, printing is one of the ways that we debug our software. So I just type it here, save, and I'm going back to my console. I click play, and it's gonna give me the values, the distance between the two objects, the player and the enemy. So the distance right now is 4.92. If I just move forward, you can see that the distance decreases. So suppose that if I just go in a distance less than 3, or what is the value that we're using? Give me a minute. The value is 2. Okay, so if I go to a distance less than 2 to 9, yep, starts moving towards me. So if I change the distance, you can you can change the distance and see how things behave. Now let's go back to our script. So this is working, which is good for us. As I said, we have this current difficulty and the proposed difficulty, and we need also this random speed and detection range. So we'll use the start method in order to optimize the difficulty of our software, or maybe I have to write the code after this line of code. So what we need is that first of all we need to generate some random numbers that are within a range. So I will create the random speed first, and to create the random speed I will use the method which is called random dot range, and within here we put the minimum and the maximum value. The minimum value in my case it's 1 and the maximum value is 10. I'm using 10.0 and f just to denote that is a float value and not an integer, and I will do the exact same for the random detection range. So again I will need the random range. I will copy paste this. I will keep right now for my method random values between 1 and 10, at least for this example, and I will create another example that I will optimize the weapon of our player using different random ranges, and I'll show you how to normalize the values and use the normalized values in order to compute or to procedurally generate a weapon that is controlled by a single value. So in this case, once the application starts, the system starts and generates random numbers. So keep in mind that this is start, means that this method runs at the beginning and doesn't run all the time. It's not like the update that runs 60 times per second. The next thing is that we need to create a global variable, or somehow incorporate in a global variable both the random speed and the random range, or the difficulty of the game. So I will use this proposed difficulty for now, and I will say that the proposed difficulty is the random speed plus the random range. So I added both of them, so we have a single value which is the proposed difficulty that controls the whole difficulty of the game. I'm using the proposed difficulty because we are trying to optimize. We'll develop this optimizers technique that takes into account a proposed difficulty and evaluates this proposed difficulty, and in case the proposed difficulty is acceptable under some constraints that we will define, then the system accepts this proposed difficulty and is going to make it as a current difficulty. Otherwise, if the proposed difficulty is not acceptable, we reject this proposed difficulty and we generate a new proposed difficulty and so on. I mean, if you look at the slides, I think that there was a diagram that I was showing how these things loop again and again till we found the optimal solution. In our case, the optimal solution is the defined target difficulty that we have here. So our optimal solution is to create a target difficulty by generating the appropriate or by assigning the appropriate speed and detection range to our enemies. So as I said, the start method runs at the beginning, doesn't run all the time. So we need to create a loop in the start method that will somehow generate some proposed difficulties for a few times till we find the appropriate proposed difficulty. For this reason, I will use a for loop, and I'll place everything in a for loop that runs for a number of times. So I will write this for int I equal to 0, I less than. Here you define the number of times you want to run this loop. I think that for this particular problem, running 100 times, it's more than enough. And I plus plus, and I will put all this here inside our loop. So this means that for 100 times, this loop is going to run for 100 times and will create 100 random speed and random detection range. Okay, and we assume that out of this 100 random speed and random detection ranges, we'll find a combination, which is this combination random speed and random range, that is equal to 10. So this is what the optimization does, tries to find a combination of variables that is going to give us the target value we need. So the system is not the most intelligent one, so we might need to add some criteria whether a solution is good or bad. By the way, keep in mind that the proposed difficulty will never be 10. It will be close to 10, but it will never be 10. It's when we develop optimization technique, it's generally too difficult to create a technique that will give us the exact solution we need, but it gives us a solution that is very close to the one that we're asking for. So the system will generate random numbers, will generate a proposed difficulty, and then we need to check if this proposed difficulty is a good or a bad solution for our problem. For this reason, we will add an if statement here, and we'll start searching whether this proposed difficulty is better than the one we have difficulty. In our case, it's going to be the current difficulty. In this case, I will be using absolute values. I need to compute some absolute values and some absolute difference between the target and the proposed difficulty. So I will be using the mathf.abs. So this mathf.abs is going to give me the absolute value of any kind of mathematical equation I put there. So in my case, I will put here the subtraction of between target difficulty and the proposed difficulty first. So what I say here, so I start and I say I want to check whether the proposed difficulty is close to the target difficulty. That's why I subtract this. And I would like to check and see if this, I'm gonna copy and paste this here. I wanna check if this target difficulty, or if this target difficulty minus proposed difficulty is less or smaller value, gives me smaller value than the target difficulty minus the current difficulty. So I will explain in a couple of minutes what this means. Let me finish my logic here of this code, and I will explain what this if statement does. So I will check if this is smaller than this, and if it's smaller, I will say that my current difficulty is equal the proposed difficulty. The first thing that I need is this, and I would also like to print something. Before I print here, let me comment this out because I don't want to print a lot of things. I want to print here a few variables to give you an idea how things work. First of all, I need to print this target minus proposed, so I will print this as the first value, and I would like to print the speed just to give you an idea of what are the values, how the values look like, and random speed. And I would like to print the detection range, or come on, I don't need it here. I will just type range equal plus this. Okay, so what this does, what we're trying to do is we're trying to find a combination of these values that, if we subtract it from this, the target difficulty, is going to give me 0. Means that if it gives me 0, if this subtraction gives me 0, means that the proposed difficulty reached the goal, or is very close to the goal. In our case, the goal is the target difficulty. If it's not 0, means that it's not optimized yet, so it might need to to work a bit more in order to give me the result I need. The other thing I'm doing here is that I'm comparing this difference with this difference. And what I'm doing here is that, as I said, this runs for a few times and is going to generate a number of random proposed difficulties that are based on random speed and random detection range. And I want to see if there is any proposed random difficulty or proposed difficulty that is better. So the closer to 0, the better. It is better than my current solution. This is my current solution of the second term. If it's better than the current solution, I'll make my current solution this proposed solution, which is the better from the current, and I will go back here again and generate a new proposed solution. And I will check again, is this difference better than the current solution? And the current solution, remember that we defined this current solution here. If it's better, then I reassign the current solution. I reassign to the current solution the proposed solution, the optimized one. If it's not, I'm not doing nothing. I'm just going back here and regenerate one new random solution. So I will save this and I'll go back here. Let me clear this. So we are using this console to debug the software and see how it looks like. So I will play this and it's not going to run for an infinite time. It's going to run just a few times. Okay, so stop it and let's see what we have here. So when the system generates a random solution, the difference between let me also pull up this. So we have this. Okay, when we are here at the beginning, this difference is 3.2. It's not close to 0, so for sure it's not the optimal solution. Then the system generates random numbers and a few iterations later creates a solution which gives me a score 2.9. Okay, oops, not here. Yeah, here. So it gives me a score of 2.9, which is better than the 3.2, so I have to accept this one. A few iterations later, it gives me a new score which is 1.3, then 1.28, 1.09, 1.89, and as you can see, the score decreases all the time, which means that after we run the iteration a few times, we accept good or optimized solutions for our problem, and we continue. So this is how it works. I will print something more just to give you an idea of how things are working. Another thing that I want to tell you here, by looking at these values, you should also look at the speed and range. If you see this at the beginning, the speed is 2 and the detection range is 4.6, and if we sum up, they are less than 10, which is here is a 10, the target difficulty. But as the iterations evolve, you can see that if we sum up the speed and detection range, then the score becomes closer to 10. So I will clear this, change this to a value, let's say 4. And this is what I'm telling you. I want you to create this method and be able to control the difficulty of the game by using just a single value. And here I'm using a single value, which is this target difficulty. It could be 4, it could be 20, it could be any number, but this any number is going to give me the result I need. So the difficulty is 4, means that the game is not much difficult. And look at it. The optimization starts and gives us a score 3.2, 3.0, 2.7, 0.9, 0.19, 0.10, 0.003. So you can see here, for example, that is very close to 0. It's not 0, but this is considered as an optimal solution for our problem. So even if it's not 0, we accept this value. So our target difficulty is 4. So if we sum up the speed and the detection range, you can see that the difficulty is almost 4. I can run, so let me run this a couple of times. So you can see this is the optimal solution, the 2.5 and 1.49. I'll stop it and clear it, and I'll run it one more time. The solution here, the optimal solution is the 2.4 and 1.76. Clear and play, so it's going to be cleared. The solution here is going to be 2.1 and 1.3. So this is one problem we have right now. So the problem is that we were not able to reach a value very, very close to 0. And we were not able to do this because we just ran this optimization for 100 iterations. So 100 iterations might not be enough for to solve the problem. So this is another design consideration for you. You might need to change the number of iterations that you need for your particular problem. So if I just come here, I can change this 100 and make it 300. I think that 300 are more than enough. So clear, play. Suppose every time we'll have much better results. So it's 0.28. I'm gonna run it again, and the new score will be 0.1. Okay, worse than that. Let's see. 0.06. Let's see one more time. 0.05. But again, if you sum up these two values, the speed and the range, ideally it's going to give me a value close to 4. I will change this 4 value to, I don't know, let's make it 20. The maximum we can achieve is 20. And I'll click play. So 9.2, 9.4, very close to 20. Generally, as I said, it's too difficult to reach the exact value. There are techniques that are more advanced, let's say, but I think that for now you don't need to know about them. Knowing the basic optimization is more than enough. Again, here the score is 9.9 and 9.9, 9.92 and 9.90. The other thing you might need to basically I need to mention is that you can see that we print 8 values, which means that out of the 300 iterations we were able to find only 8 values that make the proposed solution better than the current solution. There is a high chance that you might find 2 or 3. So it's more likely throwing a dice 300 times and trying to find the right combination, kind of thing. So this is how randomness works. So here, every time we find solutions, we find, okay, here it's a good example. So there were only 3 random solutions that gave us better results. So let me go back to the code here. And this is what it does. We ran it for 300 times. I mean, 300 times are more than enough. I think that 100 times are okay for this particular problem. So we throw these dice 100 times, and we try to figure out, or we try to find, these variables that is going to give us a score, which is the proposed difficulty. That is as close to this target difficulty. Again, we can implement more difficult, some additional steps in order to fix the issues we have. But right now, I don't think that is necessary for this particular problem. So this was a very basic tutorial on how to optimize the difficulty of the enemy. And basically, give me. So let's go back to here, and let's see in practice how things work. I will put my player a bit farther. Okay, I will use go to my enemy. Okay, let me make this bigger. So I would say that the difficulty is 4, this value, or 5 or 6, whatever, and create this plate. Let's see how the enemy moves. Okay, the enemy. Okay, I can very easily live away from the enemy. I run faster than the enemy, so the enemy won't be able to follow me. Okay, let me change this value to 20 and see what is the difference now. The detection range is much higher, and I also want to change this so it might be more clear to you how things look like. Oops, no. What are the values? 9 and 9. There might be a problem. Let me see what's happening here. Player position, transform position. Okay. Okay, I think that I know what is the different. The problem here is that, okay, we compute these proposed values, but we never assign them back to our character. So one more thing here is that after we compute and after we optimize the solution for our problem, we need to somehow assign them to our game, and our game is makes our enemy follow the player. So I need to redefine this agent speed and agent range, so, or enemy speed value, which is gonna be here, then random speed, the finally chosen random speed, and the enemy range, which will be this random range. And actually I need to put both of these inside the if, so we assign the last good chosen values to our enemy speed and enemy range. So if I just go back to my Unity project, we can see the difference. So let me change the difficulty of the enemy. Let's make it 6. Let's play the game and see how it looks like. I'm here. I'm going really close. It looks like the value for the, what is the chosen value? Speed is 1, so it's a very small value and we might not be able to reach it. Interesting. So 1 might not be a good value. So here we might need to change the range to speed detection range to 3 or 4. Let's say 4 to 10. Let's see if it's gonna give me better results. Yeah, and you can see the speed is very low. So I can very easily avoid the character, the enemy. And now I can go back to my enemy and change this to 12, let's say. I make it a bit more difficult. Let's see how it's gonna behave. I'm going closer. As you can see, it moves a bit faster. And to be honest, it's a bit more difficult to, you should look at the here, this window. It's a bit more difficult to go away from the enemy. Okay, and let's change this value to 20, and now suppose that it's going to be much more difficult. Oops, starts recognizing me. Whoa. Now there is no way I can avoid the enemy. It follows me all the time. Okay, I was able to move outside the range. So you can easily understand how things work here, and how by changing one single value I can control two different values that are related to the difficulty of the game and the gameplay. In my case, I'm using the target, the speed and the detection range, but for sure you can use other values to control the difficulty of your enemy.